Hey everyone, my name is Christian, and today we're going to tackle an interesting problem, finding the longest palindromic substring using a given string in Java. A palindrome is a sequence of characters that reads the same forward and backward, so let's dive right into it. Okay, given a string, the task is to find the longest palindromic substring in it. For example, if the input string is BABAD, the output can either be BAB or ABA. Another example, if the input is CBBD, the output should be BB, which would be one of the even number solutions. Okay, so to solve this problem, we'll use a technique called expand around the center. We'll iterate through the string, and for each character, we'll try to expand around the character to find palindromes. We'll do this separately for odd and even length palindromes. Now let's walk through the optimized code solution step by step. So first, we're given this class, the solution class in LeetCode with the method longest palindrome that takes string s. Okay, so then the first thing that we're going to want to do is initialize a string builder. And the reason we're using a string builder over just initializing an empty string is that when we eventually loop through and assign a string value, it's going to be recreating a string for every loop iteration, and it's not the same for string builder, so it's more efficient with memory. Okay. So then now we're going to create just a standard for loop to loop through the given string. Okay. All right. And then, so we have to check for odd and even length palindromes. All right. So we're going to do that with a nested for loop. So we'll call that J. Okay. And then now we want to initialize our left and our right side. So that's going to be I, and then the right is going to be I plus j. And the reason why I'm doing I plus j is because j is going to equal 0 for odd length, and it's going to equal 1 for even length palindromes. All right, and then we'll go ahead and make an outside method to update the longest palindrome. And it's going to take the string, left and right values, and the result, which is the string builder. Okay. All right, so then let's go ahead and create our update longest palindrome method. So it's not going to return anything. We'll leave that as would. There we go. So it's going to take string s, left, excuse me, right, and the string builder result. Okay. Okay, so now what we need to do is continue expanding pointers while characters at the pointers are equal and within the string bounds. So what we'll do to do that is we'll set up a while loop. So while left is within bounds, so it just needs to be greater than or equal to 0, and right is less than the length, and we're not doing equal because the string is 0 indexed. All right, and then we also need to make sure that they're the same because we're checking if this is a palindrome or not. So obviously the left and the right need to be the same because we're expanding around the center. So to set that up, we'll just use the char at method that's built in. Java, okay, and then s char at right, so those two need to be the same. Alright, so then basically what we're doing here is we're updating the results if the, hold on, it looks like we got a, oh no, maybe that's just LeetCode being buggy. So we need to update the results basically if the, if a longer palindrome is found. So what we need to do is get an if statement, right minus left plus 1 is greater than result.length. Okay. Okay. And so we'll set this to 0. Set length. So we need to clear the existing content first. And then we need to append to our string builder result s left right plus 1. So this is appending the new palindrome. Okay, and then if it doesn't hit this if condition, then what we need to do is move the left to the left and the right to the right. So all we need to do that is left minus minus and right plus plus. All right, and then the only thing we're missing here is to return the result. So the result is still stored as a string builder type, so we need to convert that to a string. In order to do that, it's real easy. All we have to do is result and then toString. Oops, toString like that. All right, and then now this is the final moment to see if this if this works. So let's go ahead and try to submit this. Yep, there we go. All right. So as you can see, it's a pretty optimized solution. It's faster than 60% and 69% for memory. This solution has a time complexity of big O n squared and a space complexity. It's constant. It's O of 1. So I hope this video was helpful. If you have questions or suggestions, please leave them in the comments below. And don't forget to like, share, and subscribe for more Java programming tutorials. Thank you for watching.